Hey everyone, Peter Chualau here. As a cloud engineer working on both AWS and Azure, I often encounter interesting challenges. Today I'll share how I tackled cross-account S3 object copying within an AWS organization using Identity Center federated users. The other day, I had another team approach me as they needed to copy S3 objects across to another account within our AWS organization. While I was familiar with Azure's approach, AWS handles this differently and with more complexity. AWS provides a procedure for this, which I've provided the link in the description below, but it didn't account for two critical aspects of our environment. One, we use Identity Center federated users instead of IAM users. In fact, AWS in their online procedure acknowledges in a warning that says that an IAM user with programmatic access and long-term credentials pose a security risk. Secondly, our S3 buckets use KMS keys with their own CMKs or customer managed keys. New buckets created since January 2023 are encrypted by default anyway. And the default S3 managed KMS keys that come out of the box will not allow us to configure the KMS policies, which means you're not able to use this type of KMS keys in a cross-account copying scenario like in my case. I created a complete solution that addresses these challenges. Let's walk through it step by step. What you're seeing is a diagram that describes the AWS prescribed procedure and how to get our user to copy files from one account to another. On the left, we have our source AWS account. Inside, there's an S3 bucket filled with the objects we want to copy. Critically, this bucket has a bucket policy attached to it. This policy is like a gatekeeper. It controls who can access the bucket and what they can do. The bucket policy allows cross-account IAM role access. Over on the right, we have the destination account. We have an S3 bucket ready and waiting to receive the copied objects. Above it is the cross-account IAM role. This is the magic ingredient. In the destination account, we create an IAM role, which you think of it as a persona or set of permissions that we can grant to users or services. This particular role has a policy attached to it that allows it to be assumed by a user or service. Above the role is the IAM policy. Attached to the IAM role, which has the assume role permission. This allows the user in the destination account to assume the IAM role. What's missing in this diagram are the two things I've mentioned earlier. One is instead of an IAM user, we have an Identity Center federated user. And the second, well, each bucket has its own customer managed key for encryption. Basically, the flow is our user in the destination account says, hey, I want to become this cross-account IAM role. AWS then checks if they're allowed to assume that role. That's what the IAM policy in the destination account dictates. If allowed, they temporarily gain the permissions of that IAM role. Now with those temporary permissions, they can access the source bucket because the source bucket policy trusts that IAM role and copy the data over. But as we will also find out, that role, that permission rather, should allow it access over the KMS key of both the source bucket and the KMS key of the destination bucket as well. Now that you have an idea how this flow looks like, we're going to switch to and show you on the AWS console how it's actually done. Okay guys, welcome to my lab. I'm going to show you what I've got in my lab. So here on my browser, I've got 4 tabs open. The 3 tabs are the accounts where we'll be interested in. So this first tab where I'm at As you can see, the account number starts with 5047. This is where my management account is. This is where we will set up our identity center permission set. The next one is the account that starts with 7819. This is where this is where our source S3 bucket lives. And the third tab, the account starting with 1450, this is where our destination S3 bucket lives. So let's start with the source bucket. Go to the S3 console, and as you can see, I've already pre-created the source bucket with a descriptive name, my source bucket. And if we go in there, we'll see I've created dummy files in there that these are the files that we want to copy across to the destination bucket. We'll just have a quick look at the properties and what permissions have been set here. As I've mentioned, we have default encryption here using KMS, and this is the encryption key ARN. The rest are stock standard configuration. The rest are the default configuration. And the next one, we will look at the bucket policy. As you can see, it has some policies defined in here, which are just saying that unencrypted calls to the bucket are not allowed, as well as requiring TLS 1.2. So let's now have a look at the destination bucket. Again, it is named descriptively with my destination bucket, and there's no objects, nothing yet on this destination bucket. Again, we have encryption with KMS configured on this destination bucket, and it has its own encryption key. The permissions, it's also the same as the source bucket, where unencrypted traffic is not allowed and it requires TLS 1.2 or higher. Next, I'll show you my management account. We'll go to IAM Identity Center, and I'll show the permission sets defined here. There's only the administrator access. Okay, so here we are in my script. We can skip this part where I created the environment, created the bucket, created the sample files, created the destination bucket. What we're interested in doing and looking at now is to create the identity center permissions. So why are we creating this? Identity center permission set? This allows assuming the IAM role in the destination account and assigning it to the destination account in the group needing access. Okay, so we will now log in with our admin account with admin privileges. We'll just configure these variables so that we can create the permission set. So this command actually creates the permission set, and then we're just putting an inline policy to the permission set. With this policy statement saying that allow this permission set to assume this role, and this is the IAM role that we are about to create in the next step. This is the IAM role in the destination account, which I've just named as account B. And we have this cross-account role name called cross-account S3 copy role. And I'll just quickly check that I've successfully created the permission set. And now next we will be assigning the permission set to the destination account. So you can see here, we're just using the permission set's ARN that we've captured above, and I've pre-populated this admins group ID variable with a value of the group where our team, that other team that needs access and need this ability to copy objects across to another account, so that they can sign in with their federated user account and assume this role and be given this permission set. Next, we'll just verify that our permissions assignment was done correctly, and this is the group ID that I have preset earlier. I'll just quickly show you what I am logged on with, and as you can see, it is the user ID here saying it's an admin-my name. Next, we will log on with our test user account. And quickly check that our account, as you can see, this is my test user. It's called Adele. And we'll just quickly get Adele to sign in to her AWS account. As you can see, Adele here has access to Sandbox 2 with that account. But because we haven't created that role yet, Adele can't do anything. She can't go and see any of the buckets in this account. And as you can see, she can't see anything in the console. Anyway, just that is just to show that Adele has the permission set given to her. Adele will be doing everything by the CLI anyway, so she doesn't need the AWS console access. Next, we will create the IAM role for the cross-account access to the source account. Why are we doing this? This will be deployed into the destination account using CloudFormation, and the template requires parameters for KMS keys and S3 bucket configurations. So let's start by logging on with my admin account again. And now I'll be deploying this CloudFormation template into the destination account, and we'll just quickly look at what this account gives us. So we create this role in the destination account. We create the role via CloudFormation template. Let's have a quick look at the template. So in the template, it looks for these parameters that CloudFormation will need for configuring our IAM role with the permissions it needs to the KMS keys and S3 buckets in the source and destination accounts. This is the template for the IAM role. So the parameters: IAM role name, source bucket name, destination bucket name, the ARN for the KMS keys for the source and destination. Now this section creates the IAM role. This is just the default assume policy. So as you can see in the policies section of this IAM role, we are allowing KMS encrypt and decrypt onto the KMS keys for both source and the destination. We are also giving permissions to the source bucket, as well as giving it permissions to the destination bucket. Okay, now we're going to create the IAM role. Now we're going to deploy the CloudFormation template. Let's look on the console to see the progress of the CloudFormation template deployment. And it is already created for us. As you can see here, it has this role. It has this permission. So it's got the KMS permissions as well as the permissions to the source bucket as well as the destination bucket. Okay. So this next one, we'll just populate the ARN of the cross account role that we've created via CloudFormation. Just checking the IAM role was created successfully, and also verifying that the policy that we've defined has been attached to that role, and it has been. All right, now we will try and perform a cross account copy. All we need to do is assume the role. Actually, let's use the AWS STS getCaller identity. Run that first. This tells us who is logged on at the moment. So we want to log in with our test account. So for this purpose, I will log on with Adele's account. As you can see, this is Adele with her permission set role. It's called cross account S3 write access. This is the identity center permission set that we've created for her. Okay, let's now assume the role with the AWS STS assume role. Run this. It's still using my permission set role. Now we will set the values for AWS access key ID, AWS secret access key, and AWS session token variables. We're doing this to temporarily assume the IAM cross account role we've created and use its permissions. If we call the getCaller identity again, it now gives us the assumed role. So now we're ready to try and copy S3 objects across to another account with this AWS S3 CP command. And now we got an error. It's telling us a fatal error has occurred, and because it's denying access when you're calling the list objects v2 operation. So it fails with an error. Fast forward a few hours of troubleshooting, reading several documents and trying out several things. And what do I find out? So I find out that it's missing permissions on the source bucket because the cross account IAM role on the destination account needs to get objects on the source bucket, and missing permissions on the KMS key of the source bucket. In order for our cross account IAM role to get objects, it also needs to be able to decrypt the object with the KMS key, and so it needs permission to the key. So to fix the error, first we'll need to unset those AWS variables for assuming the role. So we will update the source account bucket policy and KMS permissions. We'll do that with an updated CloudFormation template for the source account. We will just quickly deploy that CloudFormation template and have a quick look at what the template has for us. All this does is gives an additional statement for the KMS key, which is allowing the cross account role, which we reference with that cross account role ARN, to decrypt the key. And we've also given the S3 bucket policy an additional statement here, allowing access again of the cross account role ARN to list the bucket and to get the objects in there. Let's have a look how our deployment's going. It has successfully deployed the CloudFormation template with the updated S3 bucket policies and KMS policies. All right, let's go back to testing. So now we will log on with our test account again, then assume the role, get caller identity again, and as we can see, it is using the cross-account S3 copy role. Let's now try and do the copy. Boom, and this time it works. This solution offers a complete real-world approach to cross-account S3 object copying using identity-center federated users. It addresses the complexities of KMS encryption and adheres to AWS best practices for security. I've shared the script and templates I've used on GitHub with a link in the description below. By sharing this, I hope to not just save you time if you're faced with a similar problem in the future. I also hope that I've helped clarify a few concepts for you, like IAM role permissions and assuming roles, and S3 bucket permissions as well. Hopefully, these will help you become a more effective cloud engineer. Remember, real-world scenarios often require creative solutions that go beyond standard documentation. Till next time, hope to see you again in my next video.